Another sorting algorithm, it's a sorting by selection. So in this algorithm, we're starting from, for example, this sequence of numbers, and we have to make it sorted like this one over here on the picture that I'm showing in the screen. So the way we are doing that sorting algorithm is we have to start from the element 0 in the array. It has the value 4, and we have to compare that with all the rest of the numbers. So we have to do that 6 times, right? But every time we're gonna have that index move to the next one. So we have to start from the 0, right? The 0 element has the value 4. So we have to start comparing that 4 with 9. The 4 is smaller, then we don't change it, we don't swap it. So if the 4 is smaller than 7, we don't swap it. If the 4 is smaller than 6, we don't swap it. If the 4 is smaller than 2, then we don't swap it. But in this case, it's bigger, then we have to swap. And we have to check it one more time with the number 3. But it's already 2 here, so 2 is smaller than 3, and we don't swap it. That's the way it works for that 0 element. Then we move on. We already have that sorted. We don't take care. We don't want to work with this 0 element anymore, and we have to start working with the element number 1 for our array. And this element number 1 has a value of 9. So now we have to check and compare 9 with all the rest of the numbers, and then eventually, as you can see, the smallest here is the number 3. So we're doing comparison with 7, with 6, with 4, and then with 3, and then we can see that number 3 is the smallest one. So we change that 3 with 9, and eventually we have 2, 3, and all the rest numbers over here. Then we're doing that the same for number 7, right? Number 7 is bigger than 6, but it's smaller. It's bigger than 4, and it's smaller than 9, right? So the smallest here is the number 4, so we're gonna swap it 7 with the 4, and then we're gonna swap it 6. We're not gonna swap anything for the 6, and not gonna swap anything for the 7 because it's already in the right position, but we would also check the rest of the numbers. And that's the Java algorithm over here. Let's take a look how it's implemented. So first is the external loop, right? This is the external loop, very simple, starting from a 0 element and going 6 times, right? So 1, 2, 3, 4, 5, 6 times. That's exactly the number of current iterations, right? I is the number of current iterations. We're gonna have 6 iterations for this example. And then it's important to keep the position, of the current element that we're gonna check, right? This is the current element here, this is the current element here, this is the current element here, etc. And the minimum value, this is the value already gonna be. The minimum value we always consider as the one that is a current. So in this position, in this case, this is the minimum value. Then we're gonna have this minimum value right before going and comparing, right? But this is internal loop, and that's where we're gonna do that comparison, right? Exactly the one where we're doing that 4 compared with 9, 4 compared with 7, 4 comparing with 6, etc. So that's internal loop, and inside we are doing that comparison. Who is bigger, the current element or the one that is in the current in the internal loop? And if that's the case, that the element is bigger in the internal loop, then we're doing that swap. So that's what is going. So we have to keep the position of the smallest one. So eventually we have that position of the smallest one, we have the position of the current one, and we are doing the swap over here in these lines. And you guys can do the debug in your Java program. There are 2 classes, selection sorter and selection sorter test. In the selection sorter test, you have 4 different kind of arrays that you're gonna pass to the sort method, and the sort method is the one that is over here. So put some breakpoints and try to do a debug in order to make sure that it works in the right way, in the way that I have described with this picture. Hopefully you like it. Thank you very much.